Ma'am, can you share your presentation, please?
Yeah, yeah, yes. Yes, yes, yes.
Ma'am, please share it from the beginning.
Yeah.
Ma'am,
Is
please
it
go to the
visible?
first slide. Ma'am, can you go to the first slide,
Is
please?
this one?
First slide, ma'am.
Is it visible
Okay,
now?
ma'am. No. Okay, ma'am, please start.
Um,
Bapita, ma'am, you have stopped the presentation.
I stopped because it was not visible for me. Now
Okay,
visible?
ma'am, start. Yes, ma'am, please
Yes.
start.
Okay, thank you. There is a network issue that in all office has some network issue. That we face. Uh, this is a mechanical filtration. We can see here there is a rotating drum where you have a solid outlet and the dirty water will be going outside through this and then there will be the good water will be clean water will be going to the other side. So we can see here two types of filters. One is this fixed bed biofilter and the next one is moving bed biofilter. Here, moving bed biofilters like you can see moving, it will be keep on moving and there will be good oxygenation into it. It is more effective. If you see when fixed biofilter and moving bed biofilter, this is better for fixed biofilter is best for the reactors. You know, when you have a reactor based system, but when it is going for a normal batch system, you can go for a moving bed filter. That is the best one. And this is a degassing, just oxygen stepping only, carbon dioxide stepping and oxygen injection. And these are the UV thing, like if you want to control the bacteria, definitely we have to control the bacteria and virus in the host recycling. So if at all we are going for any shrimp farming and all using rats, it is very mandatory that we use. I mean, everywhere it is mandatory, but we should have a very good control over the pathogens. And this UV treatment, you can go for a system like 2000 to 10,000 micro watts per centimeter square. That is the capacity what you can go for. And as for the requirement of how much flow rate is there, based on that we can adjust it also. And some of the things are like we can adjust the flow rate, we can put a timer when to circulate, when to recirculate. All those things we can adjust with the help of timers. That is how automation happens. And along with that, you can put some sensors also so that the sensor can be automated with the help of nowadays apps are available. So we can go for the app-based sensing of this various activities of the RAS system. We can monitor some people will be monitoring the fish behavior, some people will be monitoring the fish eating, feeding habits, and based on that, they will okay, when to feed, how to feed to saturation, what time to feed. Everything will be organized, automated based on the nowadays many AI-based tools also available. We can go for in automation of this particular various habitat. Many people will mainly deal with the fish feeding and the fish movement, fish behavior. These three things will be based on that they'll make the algorithm and they'll visualize it under with the help of
Ma'am, your
Android
voice
camera.
is not clear.
Uh, Again, network gone. Okay. One minute, network checking. Is it audible now? Am I audible now? Can I go back once again and join?
Can you please more louder? Ma'am, please unmute.
Now visible? Screen visible?
Hello?
Screen visible?
Ma'am, you are not audible. No, no, ma'am. No.
Visible? Visible now? Amrita, is it visible?
Hello.
Amrita, is it visible?
Yes, ma'am.
Species mainly suitable for rats include by one army, of course, different types of fish. Rachis canadum cobia, silver pompano, tilapia. Tilapia is well suited only when we aim at higher size, very big size. Okay. So pearl spot, fungus, rainbow trout, marl, anabas. But anabas also is a very good candidate species when its price is very good. When price fluctuates, then you cannot go for anabas. So marl, of course, is a very good candidate species in Indian conditions price. No? And when you go for rainbow trout and all, definitely it is always advisable. But limited cultures units are there in rainbow trout. In pangaceous, of course, many people, Indian farmers are doing pangaceous. First, what not at very good running in adults, we need better standardization and commercialization. We can see marine, of course, Pombanophobia, there is opportunity we can do, but how far it is very, like, cost investment is high in case of any of the marine species, and we need that very seed supply also. These are some of the challenges in the event of if we want to expand ranch technology. When we go for feeding and feeding in rats, we need to feed only the dry pellets. We cannot use any trash fish or anything, and balance the whole diet. It can go from like small fishes, we can start with 5% body weight, gradually can reduce less. Usually every food for other species so based on it. And when we automate, we can easily make out its the saturation, feeding habits, everything, rather than just going with the assumptions like this is how we have to feed. We can reduce the feeding, can adjust the feeding. Feed is more 60% of the cost is in feeding for any system, so we can control the cost of feeding by analyzing actual feeding. Do not overfeed and make a feeding chart is the best thing you can do. Low risk and predictably we have low risk when we go for the rat system because parameters will be under control, protected from external pathogens, and water quality fluctuation is also comparatively low. Biosecurity ensured, reduced suspended solids, and we can make other parameters. And zero antibiotic use. We cannot use any antibiotics here. That is one thing we have to keep in mind, no antibiotics. Very low water discharge and hence power consumption also comparatively low and lesser space is required. Productivity is high. The production per unit area is comparatively very high. With any RS system, we can go for around 40 kg per kilogram production, up to 40 kg. That means it starts from 25 kg per kilogram in 1,000 liters. Disadvantages, of course, there is an uninterrupted power supply requirement is there, and capital cost is very high when you make the system. Good RAS will cost you not less than 50 lakh. Quality feed, medium RAS will cost you 50 lakh. Quality feed is required, that is high protein extra diet, that is fine. That is every system demands that. Technically skilled staff is required. If you compare the cost, see power, chemicals, labor, and tank volume, everything. Advantage is there in the recirculatory system compared to conventional system. This graph indicates this. So the second technology, what is advanced sustainable technology, is biofuel technology. We can go for another technology which needs less sophistication compared to the in terms of the capital, initial capital cost to the biofuel technology. Hope I am audible.
Yes, ma'am. You are audible, but voice is not clear.
Not clear. Now clear.
Loud your voice.
Hello. Now clear. I think you want to increase the voice. Is
Hello.
it clear now? Is it clear now? Clear now? Voice is clear?
Yes, ma'am.
This biofuel technology is a super intensive production system again, which is it is depending on the high stocking densities, improved productivity, reducing water exchange, water consumption, water reuse. Here, once we take the water, we are not changing the water. We are continuously holding the system for the entire season. For example, tilapia we are doing here. We are seeing the tilapia which is produced in this tank only. So this once we take the water, we until there is a very huge requirement of emergency or something, then only will change water. Otherwise, no change in water. So this system, there is only one tank. Like RAS, we don't need so many sophisticated pumping here, there, There is nothing like that. Here we can make a unit of 7 tanks with or almost 3 to 4 lakh. Within 3 lakh, you can make a good number of tanks system. So that is the advantage. Any small or margin farmer can start the system. 15,000 to 20,000 liter capacity tanks you can make. So each tank will have a production of around 200 to 250 kg in the overall tank. So that is how the production is. If any small area farmer who is having very small area also, they can start for a 5 tank system, 6 tank system. So this is how this is another reason why Government of India also promoting this culture technology, because it can be affordable to any farmer of small scale resources. So the system converts, what they will do, they will convert ammonia, nitrate, and nitrate into beneficial product called proteinaceous feed. This particular biofloc is nothing but it is feed only. It can add nutrition to the organism because it's full of what you can say, heterotrophic microorganisms that flocculate. When they flocculate, when you give them a conducive environment of a proper carbon-nitrogen ratio. I'll tell you the science behind it. The fish will produce a lot of uh, fecal matter plus feed waste. This all will come into water as nitrogen, ammonia. So ammonia, we have to convert to nitrite, then we have to convert to nitrate. Okay. So this all have N, nitrogen in it. So when we give an external carbohydrate, so this was anything. External carbohydrate can be anything like molasses, carbon or jaggery, and anything. Sucrose, sugar can be, glucose can be, whichever is affordable. There are certain other tapioca flour, whichever is available in your area. Tapioca flour can be, or sabudana you call. And then even rice flour, wheat flour, anything which is affordable from your side can be used as a carbohydrate. This carbohydrate will provide C. So C and N, carbon and nitrogen ratio. When the carbon nitrogen ratio is about 10:1, that means 10 carbon for 1 nitrogen. Okay. Suppose ammonia is 1 milligram per liter. We are providing carbon at 10 milligram per liter. 10 150 is to 10 liter. So then CM ratio is 10:1. So you can increase it to up to 20:1, no issue. But to affordable, to reduce the unwanted carbon addition, we make it sensible. CN ratio, carbon nitrogen ratio 10:1. This this particular technology provides high density production. We can stock fish in high density. Normally, we can stock in the pond system 2 to 3 number per cubic meter. So here, what we will do, we will stock anything above 60 number per 60 to 100 number per cubic meter. Any fish. Small fishes will go for 100, 150 number also. Big fishes, medium sized tilapia like fishes will go for 60 to 80 number per cubic meter. Even fungi 60 to 80 number per cubic meter. So improve productivity from small area. We can assume that in pond system we will go for maximum 30 number, max to max 30 number in a pond system. So here we will double or triple the numbers. So reduce water consumption. We are not taking water because this bacteria, what will happen is this bacteria will be flocculating. When carbon nitrogen ratio is provided 10:1, this bacteria will flocculate. They'll produce so many extra polymeric substances to make them floated, and they also produce many substances like peptides. These bacteria, when they unite, they have n number of functional metabolisms. They produce so many peptides, so many immunostimulants, enzymes, whatever they want to make them survive in a flocculated condition. They'll keep on adding to the system. So these all will be adding immunity to the organism it is consuming. Tilapia can consume a lot of this. These are suspended flocks. They consume a lot of suspended flocks. Anabas can consume a lot of suspended flocks. Your vanani, shrimp can this kind of this kind of organisms, they can reduce the feed cost to much lower. I mean, at least 25 to 30% reduction. At least we can reduce the feed cost in using this technology. So what will happen? These microbes will convert the toxic materials into, including ammonia, to microbial protein. Further, they will increase the protein. This protein, microbial protein, the microbial protein, when we evaluate, it is having 32 to 38% protein. You all know that 32 to 38% protein is a good protein source. Partially, it can replace nicely the protein requirement from the fish meal or fish meal. Okay, so that is how in the water itself, they are recycling the water with using the toxic metabolites. At the same time, they are producing the protein in their body, so that the fish can consume also. So reduction in feed cost, reduction in protein percentage to be added to the feed, and reduction in space, water requirement, and also it is increasing the biosecurity because we are not changing any water. So it's mainly using the heterotrophic bacterial pathway. The bacteria is dominated. Bacterial culture is dominated by heterotrophic bacteria, not the autotrophs or chemotrophs. So this is how the biofloc looks in a this one scanning electron microscope, and you can see the clumps of bacteria or other organisms. It also include other diatoms, macroalgae, fecal pellets, exoskeleton, remains of dead organisms. Everything will be flocculated together. So normally we cannot see bacteria by naked eye, right? When they flocculate, we can see them. This is how it is shown, when we take, the floc. This is called Imhoff cone. It's a tapered cylindrical cone, which is having 1 liter capacity, but it is graded up to 40 ml only. Though it is solid, we call it as 40 ml per liter. Okay, because it's in a semi-solid form. You cannot say it is liquid also, it cannot be solid also. You can see above there is a settling phenomenon. It will come close, they'll flocculate, and then settle like that. Okay. So this concentration of this bacteria in a cubic centimeter can be of 1 crore around. The cubic centimeter can imagine the volume of water. Within that, there is 1 crore bacteria. That is how the bacteria flocculate. So this is one tank we have made HFCIC in collaboration with Government of Kerala. We have been part of the Sudiksha Kerala project. So we have made more than 3,000 units of this biofloc units during COVID pandemic time, 2020 to 2023. Successfully, we have run many places this biofloc system for tilapia. So that times tank, you can see the tank construction is specific, and this is having this is a 5 meter radius tank, 5 meter diameter, 5 meter dia tank, and we have it is made up of you can see the GI sheets and the GI bars, and also it's a styrofoam shock absorber, and then we will put the liner. You can see the liner, green color liner here. Green color liner here, and this is phone liner. Okay, so this is made up of HTP or nylon liner also available. This is HTP sheet also available. Nylon, it should have minimum of GSM 550 to 600 GSM grams per square meter. That is the capacity. We have to tie it properly, and so that it will not. And in many places we have a high sunlight base, so we have to cover it with the sunlight, as well as the rainwater should not enter into the system, because it is highly managed by the chemically managed system, so we cannot change the various activity, various qualities of the water. So what we will do, there will be a central drainage. We have to see very carefully. This central drainage is very important because we have to drain the water anytime, and so we can see here on drainage outside outlet is also there. So through this outlet, the water will be drained out. Assignment required, not all water. Sludge is the drain. You can see all the tanks will have a central drain. The central drain is there, and we have to drain it in a proper way so that the fish will not go, or shrimp will not go out. Okay. So if you go for the fish culture, 20,000 to 30,000 liter tank is fine. But if you are going for shrimp farming, shrimp culture in biofloc, we have to go think about a bigger tank of 1 lakh liter capacity, 50,000 liter capacity. So here what we do, continuous aeration, 24/7 aeration is must for this system. And nowadays we advise the farmers to have a renewable energy system, and any solar will be connected so that they can afford the electricity. And then this type of aero tubes will be provided so that they will power up. There is no aeration fully, the system will be aerated fully. You can see the drainage system here. This is how the drain will look. We will have a proper drainage. And for a 6 tank of 20,000 liter each, can run very well with a 3 to 4 HP pump. So you can go for root blowers, and out of the 2 HP can be controlled by 2 or 3 HP can be controlled by the solar power plant of 4 to 5 kV. So that is a measure if we want to afford it. You can see very well here the drainage facility properly done here, and the liner is tied properly so that it won't go, and the drainage very well, and the aeration system, everything is set. And the sludge, normally we'll remove 100-liter sludge, 100-liter sludge every third day or fourth day. That will be fine to control the water quality. While sludge removal, we have to give the aeration. Otherwise, all the time aeration will be on. Or feeding time, we can give a break to the aeration, 20 minutes, 25 minutes. And then we can, during feeding, we can power off noise. Depends on the, if there is a lot of flock, then power off cannot be done. Flock is under control, then we can do power off. This flock will settle also very fast now. So once it settles, immediately it changes its qualities and sludge. So we have to immediately remove the sludge. So this should have a shading possible. The lights and all should not be coming from sides also. It will affect it. First what will happen when we'll make an inoculum. So this is how we will make an inoculum with the pond soil. This is we are resorting to the pond soil based technology. We'll bring the pond soil and we'll make an inoculum by making a slurry. We'll add some calculated amount of ammonium sulfate, and for jaggery will be fermented like this. Maybe for this is 4 kg soil, and for inoculating 20,000 liters, 4 kg soil is sufficient. So we'll inoculate it in a 200-liter capacity, 200-liter water, and it will have a 10 gram of ammonium sulfate and 100 gram of carbon. Jaggery. Okay, so we'll just ferment it with a pinch of yeast and then add it. So the inoculum is once ready. What to do? We'll add to our big tank. Okay, big tank, what will happen? There is a process like algal growth. First there will be algal growth, then there will be a transition into foam formation. Then once the foams are formed, it indicates that until there is a bad smell of foul smell, there is the foam formation indicates it's a good quality foam. Then flock formation, then brown color. So the brown color indicates it's a very good quality foam. To control, thumb rule is like 1 mg per liter of ammonia is there in the water. You have to have 10 to 20 liters per liter carbon. That is fermented. Sugars like molasses, sugar and sugar you can add directly, glucose you can add directly. Rest of all the things we have to ferment it because they are not very assimilable sugar. So in how to make them, bacterial assimilation, it is easy if you are able to provide them, assimilable. So we can see the fish stocking. What we did when we extended this technology to the farmers of Kerala, then what we did, we have made sure that our fish are disease free, and we did a nursery rearing. Almost they were 5 to 10 gram size. Finally, we stocked them. We stocked them everything. The guidelines were all formed, and we were issuing the guidelines for tank formation, stocking, carbon nitrogen manipulation. Everything we are giving the proper guidelines so that the farmer could manage area. The targeted production of 400 to 500 kg, but many farmers got 300 to 350 kg from 20 cubic meter tank. Targeted of business, but of course we are able to get 300 350. That is also very good. We are new to this technology. And itself is a very good amount because we cannot aim at very high carrying capacity also there. So then farmers were advised to stock always nursery reared stock, and flock volume is normally we say for flock volume 5 ml per liter, we have to manage the CN. 1 milli, how much milligram is there in your tank? Extrapolate for your tank volume, and then add that much of fermented starch. That is the thumb rule to maintain the CN ratio. Without fish also you can maintain the CN ratio. We added already the soil and soil microbes. So only manage the CN ratio, but aeration is must. And when we select species for this particular technology, consumer acceptance, marketability is the first and foremost thing. So to consume flow will reduce the cost of production, ability to tolerate high density, ready acceptance of compounded feed, fast flow, better food conversion, and diseases. These are the conditions for accepting any species selection is like that for any system. For the biofloc like the high-end intensive system, you need consumer acceptance and market. These are some of the species which are regularly done for under we will add some more in the city of fish. We have big tilapia, red tilapia, amur carp, fungus, marl, and as that magur and anabas, and we have marvel also, we have shrimp also. Okay. So when we do the BFT thing, important things are there. Like if any flow extra, you have to reduce feeding. If any low temperature is there, reduce feeding. Regulate ration to 3 intervals, and don't overfeed. Don't feed the fish at a time. Feed fishes with balanced nutrition, and only pellet feed is available in pellet feed, except for sinks where we have to use no other option, sinking feed. Lack of feeding, observe the water quality. So these are some of them. You can see the biofloc asset is a very rich source of protein. 32-38% is protein is there. We can feeding rate, we can nicely reduce 1% less than what normally we feed in conventional feed. Protein also is conventionally we give 35%, you can start with 30%. 5% you can reduce very closely. This is how the water quality will be checked. If the total ammonia nitrogen rather ammonia is normally conventional system we say it can go up to 1 ppm only max, no? But we can go up to 4 ppm in our biofloc system. We can give proper aeration, phosphate sludge removal, add carbon source, can control it. We can add more carbon source, then it will be the ammonia will be controlled. Nitrite also same. We'll say 0.1 ppm in the conventional system. Here up to 6 ppm, nothing will happen. Nitrate also up to 60 ppm. We'll say 1 ppm, up to 60 ppm. And very important parameter is alkalinity. Bacteria will consume the alkalinity, reduce the pH. So the pH buffering capacity will be reduced in the system. So for that, we need to add some dolomite or sodium bicarbonate to correct the pH and alkalinity. So we advise the farmers to refer to the initially itself to stabilize the pH with the dolomite. Gradually, if any sudden alkalinity drop or pH drop is there, then we have to correct it with sodium bicarbonate. This is option. So these are the thumb tools. Like initially you can maintain carbon nitrogen ratio 15:1, later on you can reduce to 10:1. And flow volume, as we saw already in the remove cone, you can make it reach up to 35 ml, nothing will happen. But if it is always better to control the flow volume within 20 to 25 ml per liter. Okay. Whenever flow volume is very high, then you can just cut off the aeration and for 20 minutes and reduce it. Remove the sludge, maybe 100 to 200 liters sludge. And it's higher than 1 milligram per liter, external carbon source. Usually we add the frequency of carbon source addition will be more, like every day or once in 2 days. Gradually reduce it to once, twice in a week, twice in a week, twice in a week, and twice in a week, and once. Like that we did, depending on the because it's stabilized. Once Am I audible now?
Yes, madam.
Audible, audible, madam?
Yes, yes, ma'am.
Hello. We reached
Continue.
up to here, no? We were
Hello.
audible. I mean, I was
Continue.
audible up to here, no? Okay.
Yes, yes, madam.
So these are some of the
Kerala সম্পর্কে কইতাছে চল
someone. Can you mute? Hello. There is some disturbance.
লাইভ
Hello. Hello.
কত করছিলা
Please continue. Others, please mute. Hello.
Some disturbance is there.
না না এখানে না না বালা গান গাইতে পারে না সাথে ফাস্ট হইতে পারে কিরে পারো তুই
Excuse me, who is talking? Can you please mute? Hello. Amrita. Am I audible now?
পাঁচ বড়া পুরো সময়
Madam, please
মারে
continue.
Okay. Some disturbance we are not able to hear. Yeah, and when in bioflow system, it's also not away from the stress. When the fish is under stress, you'll have anorexia. That's the first thing what you observe in a bioflow system is anorexia. Fish will become not feeding the whatever food you are doing. So that is the first observation that something is wrong. So when you observe this anorexia or not feeding, so first thing we have to observe is whether oxygen is perfect, aeration is perfect or not. Some blockage is there somewhere or not. Wash your electric system and all, and then keep it back. Then we have to observe secondly, we have to observe the pH has reduced, dropped very badly. Not pH we need anything about 7. So 6 up to 6.5, it's dropping is okay, but less than that, it is very stressful for the fishes. And the third thing what you can do is you have to check the ammonia. Ammonia level is high or not. Then ammonia level is immediately carbon nitrogen ratio you have to manage. Then further there is some problem is we have to do the specific treatment based on the difficulty observed. So many times the farmers will fail in the system because they are not able to manage the feeding. The feeding sometimes is not proper. When they give excess feeding in RAS and bioflow, when they give excess feeding, the whole systems the equilibrium will drop. The equilibrium drop means when fish will have a more tendency to be stressed. So the stress to be avoided. Then this is on some of the instances of what we have done in the Kerala success story of unit. We have
আমি একটু কালকে আয়া পড়ি
some of the
আমি একটু কালকে আয়া পড়ি মা আমার তো গান
observations and
গাইতে
all.
লাগবো না
Then since we are going to produce success, we can be very healthy and very active. And we were doing all this in online mode. Most of the classes were taken and the guidelines, everything we set for.
টিম অফ প্লেয়ার
So some of the first made some demonstration unit in one district, one demonstration. They did first and then gradually we expanded it. Every month the farmers were given the technology. So like that we have reached to 3,456 units. Now there are more units because many people are doing Manami. So many units are there. We can see the average production of various districts. Also, it has reached to 7. I cannot show you it is good. 20 around 20 to 22 kg per cubic meter we are getting on an average. But many places some places we got even 26, 27 also. So that is per cubic meter. So we have done we can say the stocking of fishes in the 25 kg production per cubic meter. So accordingly we have to decide which small fish means small number, bigger fish means medium fish means medium number, and the small fish bigger fish means small number we have to show. So Tilapia also we are in India as such, we have only improved strains to be done. Monotype tilapia and this tilapia and Chickalada strain also we have done, and that also was successful. Growth rate is quite good. And we have attempted at CIC again, we have attempted semi-biofloc culture system for open water of shrimp, open water culture of shrimp. There also we have found successfully. We have made developed our own conditions to do this particular culture. Even without light cutting also, it was working very well. So these are some of the glimpses of biofloc, and now we'll go into aquaponics. Hello.
The balance for
Kindly unmute
DCK.
mic,
Yes.
please.
A
Sorry,
team of
can
players.
you mute your mic?
CREW. A dash of room की collectors. Switch balance for.
Aquaponics is another
Yes.
aquaponics is another technology where
A
we will
bundle of sticks है. अभी तो ये बड़ा केम ना है हैं?
aquaculture with agriculture. Am I audible, Mutla?
Audience. An audience
Someone
at a
is keep on
concert.
talking. I'm not able to
A
concentrate.
crowd of people in a market. A shoal of
Amrita.
shoal of fish. और क्या ना
Aparajitta. Hello,
Can
Dr. Aparajitta.
if the person who is talking continuously, actually I'm not able to concentrate also.
A school of
Definitely
teachers
that
है ना?
complete that voice will come.
A group of dancers है की हुआ है?
Dr. Aparajitta.
Troupe, TROUP.
Not able to see who is
For a
talking,
player
but
है
someone
की
is
हुआ है?
talking.
Flies ray swarm. Hive or cluster of bees swarm. A suite of
I have to continue the
lion
integration of
Dr. Aparajitta.
Shoe ऐसे तो
actually
ही है. Fruit trees, a group of fruit trees.
hello. Amrita. Am
And
I audible, Amrita?
orchard. Data. Orchard কিটা orchard. তো কইতে পারলে না তো. Orchard of fruit trees, group of dancers কইতে পারছিস না. আর a group of wolves, dogs, hounds, cards. এটা কি? হ্যাঁ? A dash of wolves, dogs, hounds, a litter of puppies. Oh, puppy, a group of puppies, kittens কি কয়? A dash of geese. A group of geese. A dash of geese. A gaggle of geese. A dash of sheep or birds. A group of SHEEP or BIRDS. Sheep or bird. Flock বলছি তো. Flock হবে. A dash of bird. Bird.
Hello. Am I audible? ഹലോ അവരെ മ്യൂട്ട് ചെയ്തു. അവർ എന്റെ ചെവിയിൽ ഭയങ്കര സൗണ്ട്. ഇത് തന്നെ എനിക്കൊന്നും കേൾക്കുന്നില്ല. അവർ പറയുന്നത് എനിക്ക് കേൾക്കും. ഞാൻ മ്യൂട്ട് ചെയ്തു അവരെ. ഞാൻ മ്യൂട്ട് ചെയ്തു. ഇനി ജോയിൻ ചെയ്യാം. ഓക്കെ. Amrita, audible now? Am I audible now? Yeah. Good to continue. I felt little bit so much disturbed because of the headphones. Somebody was talking, then it is very difficult to concentrate on what we are talking. Uh, so, uh, so we'll come to aquaponics. The integration of aquaculture with agriculture. In aquaponics, what we will do, the nutrient-rich water from our aquaculture system, which is nutrient-rich only anyway, ammonia, nitrate, nitrate. So what the plants need is nitrogen, right? So, and also phosphorus also will come along with the feed. So these two things are required for the plants that will be provided by the water from the fish use. So we will these nutrients will be recycled by the plants for their growth, and fish will be healthy because we are getting the water cleaned. So in aquaponics, simply what will happen? What we will do here, we will have an aquaculture tank, fish tank. From the fish tank, water will be pumped to the hydroponic bed where the plants will be grown. The plants can be anything. It can be fruiting vegetables, non-fruiting vegetables, leafy vegetables, or it can be high-end plants of flowering plants, or anything which can be. Even some people do the seaweeds also. Seaweeds also we can do as part of the system. So it is just an integration. Okay. So what will happen? The waste produced by the fish will be converted by bacteria uh, in in the roots or in this hydroponic bed into ammonia, and this sorry, ammonia into nitrate, and then the nitrification process will happen in the hydroponic bed. That's it. Whatever nitrification process we do, that will be happening in the nitrification hydroponic bed. So that will be converted, and it will be safe for the fish, and the water will be returned back. So the water level will be controlled with the bell siphon. Advantages varies from the fish is used by the plant. We'll get additional crops. We'll get the water will be recirculated, and local economy can be enhanced and reduce consumption. Moreover, we don't need to add any extra fertilizer or any medicines to the plants, except some of the foliar sprays which are required in terms of, for example, the fruiting plants. We need to give some potassium supplementation, some seaweed that we can give as a part of saving some minerals. A mineral addition. So such things are given. Otherwise, continuously your plants are getting organic fertilizer. We can see here media filter. This is media filter bed. So we will get a clay based media. That is little bit costly if you go for the hydroponic bed based system, because the media bed is if you go for the gravel, it is not costly. Then you have to go for the small. Then also we have to go for the small pots that are perforated well, and it will be provided with the clay granules. The clay granules have a very good support. I mean, they'll hold a lot of pore space, and it's having the bacteria. Like if you are using clay pots like that, clay granules, then we don't need any separate biofilter for it. If you are doing only gravels, then we may need a separate biofilter also for much safer side. Otherwise, clay granules, if you use, it's a bit costly and on where you see. Otherwise, you can go ahead with another system. It's called nutrient filling system. So the water will be pumped. The nutrient filling system we will show here. In this the water will be pumped through the PVC pipes which are perforated, and then we will put the plants. The plants will grow in this. This is for the plants which don't need much of soil, and as well as don't need much of water all the time. So such plants will grow very well, and we can well produce lettuce and all those things. Lettuce will be well produced in another system. We can say floating rack. The floating rack, it will be floating. A rack will be made. It can be made of plastic or thermocol or anything. We can put it in, and inside the granules we can put like this plants we can put here. This is the nutrient filling technique where pipes will be. It can be multiple layers also. Like we can put in 3-4 layers, so that will be continuously vertical farming system. Continuous full area can be utilized when we are using this. This system is comparatively little bit costly because of the bed requirement and the space. Most this is how the media film we already mentioned that we have the water from the fish tank is pumped through the filters to the here we need a filter also because there is no other filter. It's just flowing flowing through the pipes. Okay, so we need a filter here. This is a filter. Biofilter, simple biofilter, what we saw in the VAS system. So plant roots are exposed to continuous supply of water, oxygen, nutrients. More precise growing conditions can be provided. In this floating raft, we already saw this type of thermocol layers will be produced. Thermocol will be in that small holes will be there. The plants will be inside that. So these are some of the vertical growing system. You can see deep water culture. We can actually deep water culture we can do when it is for a floating raft system. NFD. Both the sides we can do that. Otherwise, those hydroponic bed system we have limitations of space and the costly material. A routine pressure washing of system components to remove any biofouling is required, or like any other culture system. Normally, plants used are lettuce, basil, parsley, mint, fruiting crops, tomatoes, cucumbers. You can go for cherry tomatoes also, eggplant, okra, basil, fruiting crops like fruiting crops anything. We have done capsicum, bell pepper, and many fruiting crops. Cherry tomatoes are very good for this. Flowers like marigolds, and also the cut flowers which they are able to do. Now, CIC is attempting strawberry also. Strawberry we are attempting, and other fruits, vegetables. Most of the vegetables we have attempted here. So even Mr. God, ladies finger, everything is attempted. Bok choy, that's a salad vegetable. So that is also per piece 100 rupees. So that's also very good. Spinach. I've attempted almost all vegetables. These are some of the fishes. You can go for aquarium fishes, and also indoor aquaponics we can make it with the help of ornamental plants and ornamental fish. Then tilapia, trout, catfish, carp, koi, and all you can use. Anyway, freshwater prawns, all this. And sometimes nowadays people are getting more interested in the aesthetic sense. So aquaponics, indoor aquaponics is also getting more. So that is one thing that also CIP had attempted. Some units have been developed. And that also gaining like per unit charge is like 25,000 rupees. Right? People are ready to buy. So such concepts are also coming up. This health management, of course, like any other RAS and bioflux, we have to manage here also. Avoid any stress condition, avoid ammonia, control ammonia. When there is any problem with the ammonia site, then we have to see whether the plant roots are not getting decayed, plant roots are not are intact, and there is no clogging in the water, nutrient filling, especially when there is some clogging is there, your plant roots get decay. So the clogging is to prevent, and you have to check the system in this. You can remove it and see it whether any clogging is there, any problem is water flow is not proper. So such things will add stress to the organism, so we can improve. Benefits, of course, two systems, fruits and vegetables, fish and vegetables, everything will get extremely water efficient, do not require soil, no pesticides, high yield, quality. You might have seen aquaponics produced spinach, this one available, lettuce available, and it is maybe 1/3 more costlier than the ordinary produced lettuce. Okay. So you might have seen in value chains, you will see lettuce which are provided. This may be 130 rupees instead of 100 rupees because it is aquaponically produced. So that means no chemical, no pesticide, no bacterial problems. It's very clear. So organic, almost like organic management, so people prefer it and charge high. That is a plus. Drawbacks there, initial expense like RAS, it is heavy expensive. Plumbing, pumps and all issues. Man-made energy. We can go for renewable energy here also. Knowledge of fish, bacteria, and plant products is needed for each farm material. So each system is different. We have to see the component ratio, we have to see the hydraulic loading rate, we have to see how much time we can run the system. We have to set the timer. Not full time, what will be keep on running is you cannot make it sustainable. You have to run it maybe 5 hours in a day or 6 hours in a day or 24 in the day. Then the system will be successful. Then how to run it, and you have to make sure that it's staying for some time and then it is coming. So in that way, we have to adjust the pumps timer. It's a time. Again, automation. Here again, combine. We have done our work in this. We have made. We have seen here the bell pepper which we produced. This research system. Okay? So what we have done in other commercial units are here. So in that we have done almost all. plants, which are of relevance to aquaponics. And here we have done, like we can say, flock ponics, bioflock system integrated with aquaponics. In this fish is also in high density. Normally in aquaponics, we cannot go very high density. Bioflock, we can go for high density. Here we can see we have used a filter. Use the filter so that the flock won't be from the back. Okay, it's flow filter with the filter. The flock was this is flock, and we have made a high density, like 150 number per kilo. It is an experiment, but it's an integration model. We can do. Nowadays, the recent advancements, if we say the integrated multi-trophic aquaculture system, it is very, like you can say, very sustainable aquaculture system. It was the concept was given by Dr. Thierry Chopin, and it is very much increasing efficiency. When you go for the commercial cultivation of pond system, also you can go for fed species, extractive species, and waste or waste regulating system. So sustainably, the fed species is kingfish, shrimp, and all. Then we go for organic extractive mussels. We can use mussels, freshwater pearl, or anything which also are comfortable with stuff. And then inorganic extractive, right? We can go for seaweeds and all in the case of marine. In case of freshwater, we can go for any which are of commercial value, which plants are of commercial value, we can use. Yeah. So economic diversification, sustainability, and all can be achieved. In INTA, we can INTA means integrated multi-topic aquaculture, which when it is done in freshwater, it is called INTA, freshwater integrated multi-topic aquaculture. And we have a complementary ecosystem function. One species eat and feed and waste will be nutrients for the other species, and then converted into fertilizer. Like it will be converted into their. And so it is production. Production is there. Economic sustainability is there. Socially acceptable. No issue. It is almost a concept of a circular economy, we can say. Circular economy means no waste. Everything is a resource. Okay. Waste management will be done within the system. So nowadays we see a lot of concepts like vertical aquaculture. Okay. So the entire building is designed in such a way the maximum area will be utilized. This can be utilized in cities like Mumbai, Calcutta, Delhi, and all. Any cities where a lot of high rises are there, where we can have a sustainable production as well as the cooling of the building. Everything can be done where we are able to produce some, we are able to construct some tanks of vertical in nature, and continuously water will be circulated with the proper design. So it is concept developed in 1999, gradually Dixon experiment. Gradually, it is getting adopted in various places, especially places of aesthetic and even breeding. People are doing breeding in such tanks. You can see in the vertical farming structure, some of them, like you can have a construction material of transparent material, so that on the wherever you do the agriculture, you can have a transparent material so that the light will be penetrated and the plants can be grown. That is one thing. And we can utilize natural and artificial lighting also. Water requirement is very limited. Dehumidification, and they'll be able to harvest the rainwater also. That is a plus point. Harvest the rainwater, recycle waste maximum. These are some of the technologies. Nowadays, it is widely getting applicable in Southeast Asian countries, Singapore and all. So this is a vertical fish farm architect that closed loop recirculation. This concept actually we have to adopt. It is a proposed concept where we can have a maximum RAS system in a vertical form, so that the production, we don't need a lot of space and water. So you can go for any type, 3-type, 5-type system where will be the nutrients will be converted into. There you have to integrate a bioflow also there, because the waste will be converted into useful thing. You can use it. This is an example vertical crab culture people are doing, and India is also India also many farmers are doing vertical crab culture. It's also a sustainable method where we will have boxes. In the boxes will be recirculating the water. Okay. Water crabs will be made into market. So that's all from my side. Sustainable way. Thank you very much. Amrita.
Thank you, ma'am. Ah, I will unmute participants.
Yeah.
Participants, you are unmuted now. Please, if you have any queries, you can ask.